We're here at the European Utility Week here in Amsterdam, which is the biggest gathering of energy companies and suppliers in Europe. We're here to see what the latest trends and technologies are in the energy sector this year. So far we've seen the trends have been the internet of almost everything, smart everything, and interesting and novel ways of managing changing trends in demand and supply of electricity. One thing we're particularly interested in is novel ways of storing excess electricity, and we're going to go and have a look at some examples now. We're at Stornetic, who have developed a novel type of flywheel which stores kinetic energy. The way it works is there is a rotating cylinder which is driven by a motor or generator in the base, which can charge or discharge this device very, very quickly, dealing with the sharpest peaks in demand or supply. What we found particularly interesting about this device is its carbon fibre construction. This confused me a little bit because when I think of a flywheel, I normally think of something steel and heavy. But if you look at the physics behind a design like this, the amount of energy you can store isn't actually dependent on the density of it. It's dependent on the maximum stress that the rotating cylinder can take, making carbon fibre an excellent choice. This is Chemwatt, who have developed the world's first commercial flow battery. The way in which a flow battery works is that chemical energy is stored in two separate fluid components, which are pumped past a membrane across which ion exchange occurs and current is collected. The advantages of this type of technology is that the fluids can be stored in two tanks, which can be scaled, the ciphers of which can be scaled depending on the energy storage requirements. They have a much longer life than traditional battery technologies, and the thing I like most about them is that the fluid components can be manufactured anywhere in the world and are completely biodegradable, so you avoid a lot of the end-of-life issues that you get with lithium-ion batteries. So we've seen two novel examples of energy storage technology. Both of these are alternatives to batteries, but not necessarily competitors, because I think they solve different problems. The kinetic energy flywheel storage system can be charged and discharged much faster than a traditional battery, and the flow battery can be used in applications that require higher reliability and higher safety standards. There's clearly a lot of space for innovation in this area and new solutions. I'm really interested to see how it develops over time.